Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone. Welcome to another session of Microsoft Reactor. My name is Bruno Capuano. I live in Canada. You're going to notice the accent, not Canadian. Born and raised in Argentina, live in Spain, now in Canada. And I work as a cloud advocate at GitHub/Microsoft. And I'm super happy because today I'm here with Don, and we are going to talk about agent, lesson learned, and how we can really build agents that work in production. So, hey, hello, Don.
Hey, Bruno. So I am Don Chouinard in Canada, and I'm happy to be here and looking forward to, I work a product marketing manager at NVIDIA and a content creator, and looking forward to doing this webinar.
Yes, and hey, by the way, thanks to Molly that is helping us in the production and more. And we are reading the chat. We are going to talk about a lot of content. But if you have questions, if you have something to share, please drop a comment in the chat. We try to answer them live. Or if we don't have the answer, like we see here, people from Adelaide here. So hey, that's amazing. Francesco, hello. And more, we are going to try to answer, or at least a couple of questions that we have in the previous session. People contact me later in LinkedIn, and I learn a couple of new things, and I have some answers, and I still need to find more. But that said, we are going to talk about agents, an agent that really don't break under pressure. What we want to share today is the story that the experience that we learned in the last couple of years building agents when we start to make them and push them to production. What we did well, were the spaces that we could do better. We can improve a lot here and there. So this is what we want to share today. And of course, we are going to talk about best practices. We're going to talk about templates. We have all of the power of NVIDIA, the templates, and more. I'm sure that there is a lot of new stuff that people are going to learn about this. This is the agenda, but as I said, it's going to go directly with starting from scratch, what is an agent, until the end, showing an end-to-end sample application that uses literally everything that we have. That said, let me go back a little and let me start to summarize in 5 minutes what is an agent, because this is what we are going to talk today. And this all started 4 years ago. ChatGPT was in the November 30, 2022. ChatGPT was online, and hey, we started to chat with an LLM, and it really feels something natural. We find that, oh my God, these transformers, LLMs, these amazing GPT models were very good when we had the conversation. And of course, they have some problems here or there. Sometimes they make up some information. They have some cut off in the data that they were trained and more, but it was a nice experience. And it started to grow. We started to have some other model from other providers and more. And at some moment, we also realized that, hey, we may connect these LLMs to external services, to external tools. And that's the moment that we move from just an LLM to do chat to something more intelligent. And after a couple of iterations, we get to the concept of an agent. And an agent is literally an LLM, picture an LLM, that has a set of instructions that is going to define what is the agent going to do, how the agent is going to behave, and a set of tools. And those tools are the ones that provide the agent capabilities like memory. Today, everybody expects when you are having a conversation with an agent that the agent remember what you talk about. If you've been talking about this and that, if you have an agent like ourselves with Copilot and my mails, my team messages and more, I don't want to explain the agent every time what I am doing, the agent should know that the memory is there. And all of this happen because they have tools. And of course, the tools allows the agent to connect to third-party services like a calendar, a weather service, or a system application and more. And with all of that, we have the idea of the agent. And how the agent is going to work? By an input, and the input can be a user asking a question to the agent, or maybe another agent, because the agent now talk between each other. And when they have all of this conversation, the output will be a response to the user, or maybe they respond to another agent, or maybe just working with tools. So this is the idea of the agent. This is what we have as an agent today. And the nice part about this is that it's super easy to create an agent. There are plenty of frameworks and tools and platforms that literally in 2 minutes you can have an agent, and everybody's so happy there. But we started to learn also that when we move to production, when we move an agent to production, we start to see, okay, this is not as easy as it was when it was running a hello world in my machine, which is good, by the way, because we got the basic ideas. But then we start to learning an example that when the agent is doing several steps internally, you may want to have some storage to store this durable action of the agent. We call them durable functions. So you can track those steps. If it's for whatever reason the user leaves and then get back, you can resume from one of the steps and move forward. So you need to implement, you need to have something to do that. At the same time is that, hey, what's happening when the agent hallucinates, when we have LLMs that are starting to make up some information. So that's where, in example, RAG gets to help us, because when the agent provides an answer and the answer is tied to the source of the document, in example, you know that that's true. That's information that is tied to the document. And we are going to see this later in one of the examples. And there are a couple of more and more examples, more lesson learning that we have there. How you deploy this, how you move to the cloud, how you get this enterprise level when you have traceability, when you have scalability and more to the agents. All of these things, all of the stuff is what not all of them, but we want to share with you some key points, some key samples that are going to help you to get there based on the stuff that we have here and there. And for us at Microsoft, what we have to create agents is a framework, it's an open source framework that is called Microsoft Agent Framework. It's GA, it was GA last month, I think on April, and supports right now C# and Python. It's the evolution of previous frameworks that we have, Semantic Kernel and AutoGen. We basically get the best of those two frameworks and we put it here, and it's open source, so everybody can take a look at the source code and collaborate and more. It's driven by the community. I really, really like how the community behind the agent framework is the one that decides where we want to go. Like an example, at the beginning, one of the key requests from the community was, hey, you need to support Dev UI, which is a super nice interface to visually debug how agents are communicating between each other. And hey, we need that. So we added there the same from A to A. Agent to agent is a protocol originally created by Google. I think right now it's managed by the Linux Foundation that define how agents are going to speak with each other, connect to each other, and collaborate. And agent framework support that. So it's driven by the community, it's driven by the enterprise needs and more. And it's really, really nice. And as I said, it's open source, so everybody can use it, take a look and more. And again, C# and Python. And the important part is GA is ready for production. So we have support behind this. And this is the slide that every time I get here, I always tell that this is a slide that you're going to spend 10 minutes, 15 minutes, half an hour speaking about, hey, there are so many ways that you can create agents. Agent framework is the one that we are going to use mostly today, plus NeMo. That's a spoiler. We are going to talk about this later. But remember, seeing that you can create agents in EAS mode or PaaS mode or SaaS mode, like an example with Copilot Studio and more. The whole idea is at the end, if the agents are compliant with a set of, an example, agent-to-agent standards, they can be able to connect and talk between each other. And where do we host our agents? In Foundry. Foundry is that part of Azure that is focused on AI. And in Foundry, Microsoft Foundry, we have Azure AI Search, we have Azure Machine Learning, we have the Foundry models, Foundry agents, and more. And because it's part of Azure, it's also enterprise ready on the sense that we can create an agent example there in Foundry. We can assign the agent our LLM and instructions, our tools, and we can assign to the agent our Entra ID. So the agent can behave like it was a person inside of Azure Active Directory in Azure Entra. So we can assign some permissions and more to the agent there. Everything that we know and have in all of the places of Azure is connected here. At the same time, all of the agent service has connection to, an example, Azure AI Search, storage, and more. So it's all connected there. So the key part here, before going to the demo, because if you know me, you probably know that I like to do demos. I like to show things live, is that, hey, inside of Foundry, we have a service that is specifically created to work with agents. It's called, of course, agent service, and allows to run single agents, around to do workflows within agents, and it's open, and it has everything that we have in Foundry around security, scalability, and more. And we are going to show a couple of agents here, just a high-level overview. And by the way, it's very tied to the models. It's very tied to all of the capabilities that we have there to scale. And let's take a look at here. Let's take a look at the demo. So the way that we are going to work today, let me explain this for you very, very fast, is I'm not well in my, I have some kind of a cold or more, so I need to have break every 10 minutes to speak. So I recorded a lot of demos. So let me play one of the demos, and we're going to see how Agent Framework works. It's a Microsoft Agent Framework sample application. This is kind of the hello world that we can use. In this scenario, we're going to create an agent locally using Ollama and LLM Studio, using one of the Nemotrons model. And as you see here, this is a C#. We have Python also here. But the idea is to use the libraries that we have here, get some endpoints and models. And once we have this, there are different endpoints for locally for Ollama and also for LLM Studio. We are going to create a chat client, and with the chat client, we're going to create an agent. And the agent is going to be a very simple agent, no tools, no skills, just an agent to do chat. And it's going to basically, the name is going to be Nemotron agent, and it's going to basically ask, get the question and answer the question. That's it. It's very simple. So if we take a look here, we have Ollama running. Here is running. Let's open the monitor to have it here, and let's run this application. So let's do app.cs with the model local. When we do local, it's going to go by default to Ollama. So it's going to lower here. We see that the model that is loaded right now is Llama 3.2. But when we ask a question, because we're using the Nemotron model, we are going to see that the Llama model is going to be unloaded by Ollama, and it's going to load the Nemotron model. So after a couple of seconds, there it is, unloaded the Llama, and it's going to load the Nemotron. And once the model is loaded, it's going to answer the question. And of course, the first time takes some time because the model is in memory. If we do this again and do something, please solve 2 + 2, it's going to be faster as the model is already in memory. Ollama is great to do these kind of things, but I also like to use LM Studio because LM Studio gives us kind of a console application. And in LM Studio, I have loaded the Nemotron 3 Nano Omni, which is also support vision. It supports a lot of other features. And I really, really like to see how this one is working. And by the way, if we take a look at the GPU, in this specific machine, I'm working on a DevBox machine. I have an NVIDIA Tesla T4 working here, which is a very, very nice developer GPU to use and work. And now we can see here the model is already there, loaded by Ollama. So let's do this. Let's close Ollama and let's switch a little to LM Studio. We have LM Studio. We have the other model here. This is Nemotron 3 Nano Omni. Yes, Ollama is offline. And what we have here is the console log for this. So when we run this, but instead of doing local, we do local LM Studio, and we run this question, we are going to start to see, like an example, let's do a hi again. We are going to start to see a lot of important information about how the model is being loaded, a couple of logs. We have here, which is the model, when it was created. We can define here the input and output as part of the LM Studio configuration. We can start to say, hey, this is the model, this is how it's going to do, the GPU that's going to use, how many concurrent predictions can be run, how many is the GPU offload here, how big is going to be the model support in tokens for the context lens. Right now it's 4096, kind of the default, but we have all of this info here. And again, this is a very simple way to use Nemotron models locally. Ollama, LM Studio, or any other provider like Foundry local if we want, and literally 10 lines of code to get here. And that was a 3 minutes, I think, demonstration of how you can use Agent Framework to work with local models. But we have one of the questions also there about, hey, what's happened when we go to Foundry? Foundry is the other place. Foundry is the place that we deploy and we have our models in the cloud. So this is the entry, the home, the entry page for Foundry. This is a project I have created. We have created a chance to deploy some models. So if I go to the model catalog and we start to see, let me go to see all of the models. We can filter for, let me filter quickly for NVIDIA. So we are going to see the chance to deploy all of the models. I already did my test in the morning. Don't so when I did my test, I don't have any more quota. I am running so many demos. I am running so many tests and agents on the cloud that I run out of my quota. By the way, this is another ping to my manager to help me to get more quota for GPUs. But this is kind of fine. This is kind of nice because I can pick up one of the NeMo model. Literally, this is one version. I think this is a bigger one because it's a content safety NIM one that I was running locally. This is one of the bigger ones. If I want to use it, I just go to use my model. A couple of clicks later, I deploy this in Azure. I am not going to have, by the way, this is a spoiler, I am not going to have quota here. I already ran out of quota to run more CPUs with models. And this is mostly because I'm preparing a couple of contents that are going to be presented at Build in a couple of weeks. If you want to join online, June 2 and 3, we have a lot of announcements there around clouds, NVIDIA, and partnership. I can't say anything, but please join us online or take a look because there are so many new things and we are cooking all of that. But hey, going back to Foundry, when we are in Foundry, one of the things that we can do is we have the list of agents that we can work, and each one of the agents, when we create an agent, and we have two ways to create an agent, a prompt and a hosted agent. Let's put a pin there because the prompt is something that is going to be very useful later. But we have an agent here. Remember when we talk about the agent at the beginning, what the agent has? They have a model here. I think I have a couple of GPTs and model router in this instance. So I have my instructions here. I don't have anything. I have my tools. This is literally, I think it was slide number 3 that we talked. I have my tools here. I can enable here for my agent memory. So the agent will have a memory, which is basically connection to a vector database. So it will learn on the time. And someone was asking questions, and let me bring this question here about Job, about how we can prepare our agent to be defensive against poison prompt injection, and more. There are different ways to do this. In Foundry, in agent service, what we have is a set of guardrails that we can apply here, and one of them is basically create one where we can define, okay, we want to make a new control to control what? We can control prompt injections or spotlighting, or we can create a block list to do manage content safety about hate, self-harm, or more. There are different tools. I don't want to talk a lot about Foundry today because it's going to be just talking about that, but we have a lot of tools that once we have an agent or once we have a model, we can apply these guardrails that is going to be at the beginning and at the end when we get an input and an output to basically validate and stop hallucination, filtering some IP contents and more, and it's all part of the platform. And by the way, every time that we are working with the client or internally and we learn something new and we have any new type of defensive or any type of guardrail that they want to make available, it will be available automatically to everyone in Azure and Foundry to use it. So this is one of the ways that I will probably suggest to do this. So maybe when you work locally and testing, don't make a lot of effort there because the powerful tools to do this are already deployed in the cloud. But I talk a lot and I show a lot about this.
And Bruno, I'll just add on top of everything you just said about the guardrails, of course, this agent is running under a certain identity, and that's going to determine the resources that it can touch. So you always have that level of security, and containers are often used to run the models. So you get, container isolation. So those sorts of things are also pretty important.
Yes, I can remember somewhere here. And again, I hope I don't show something that I'm not allowed to show. But here, if I go to one of the projects, let me try to find mine. And by the way, if you see a project that is not mine, don't tell I have my, okay. I am going to stop here because I'm entering in dangerous zone, entering a spoiler zone. So I don't want to show, but yes, you can deploy, you can apply everything there. That yes, it's going to run isolated and more. And hey, now that I have you here, John, because all of this is amazing.
I have another question for you first.
Yes, please.
All right. Okay, so now when you deploy that, of course, that's going to deploy in the Azure cloud and run up there. Now, how does that differ? I know there's a Microsoft Foundry where I can deploy locally as well, right?
Yes. So in my demos, I use Olama and I use LM Studio. And those are tools that you can install locally in your Windows, your Linux, your Mac machine to run models locally. And then we have our Foundry Local. Foundry Local is our kind of local version of, is kind of our Microsoft version of that is going to run directly in your machine. It's going to host the model, and it's prepared mostly for developer or production scenarios, because Foundry Local will automatically manage the download of the model, the cache of the model, the iteration of the model. The models that Foundry Local expose are only models that we've been testing and the team of Foundry approved they are. So yes, that's another one. And I need to upgrade my demos and also show Foundry Local there, because it's a very, very good options to use there. But yes, hey, thanks for that, because I need to add Foundry Local to my demos. I don't know if we're going to have time to put all together, but yes, Foundry Local, take a look. And by the way, Foundry Local is GA. So back to you, Don. Sorry about that.
Excellent, because I have some DGX Sparks, and I've been using LM Studio, I've been using Olama, and of course, I want to move on to Foundry Local. So I'll play with that after. But for now, let me just introduce Nematron. Nematron is an umbrella, and it contains all of these things. It's got industry-leading open models, which most people think, oh, the Nematron models, yes. But for some people, more importantly, it has massive, massive open data sets that you can use to train your models with. And I'm going to say more about that later. It also includes libraries and blueprints to use for making agentic AI happen. So the industry-leading models, some examples of that would be Nematron 3, which Bruno's been talking about, models for reasoning. So those are good, you know, when you're in the orchestrator and you've got to make some decisions. They do well there. However, if you need eyes and ears, you need to see and hear, then the Nematron vision language models can come in handy. You want to talk to the agent and have it talk back? Well, the leaderboard, top leaderboards everywhere are the Nematron speech models, actually. So they're leading the way. So they'll do a good job there for you if you want to have speech I/O. And then we have a number of Nematron retrieval models for when you're building a RAG application. I'm actually going to talk about those a little bit later. And then on top of all of the safety things that Bruno just covered, there's some other Nematron safety models as well that you can get involved. And I think I put one in the RAG blueprint, so you'll see it over there. Now, useful libraries include things like the NeMo data preparation tool. People that have been working in this area know that that's really maybe more important than the model. You know, data preparation tool, you got to get it all clean. You've got to get it ready for doing your training or doing your fine tuning. Then there's the Megatron Core training framework. We've got a thing called NeMo RL and NeMo Gym. I don't have time to go into them, but I have time to mention them. We've got NeMo Evaluator, which you use to, you know, you have to choose a model. Yeah, there's thousands to choose from. So, you know, and for what you're trying to do and for the role that that model is playing, because you're going to be orchestrating a lot of little models together. It's not like one model and then a chat no. There's lots of models involved usually. So, you know, for any particular task, to pick the best one, NeMo Evaluator, and also does industry standard benchmarking and so forth. So it's all there. You can just run it. It's very convenient. Compare A to B and see what you want to do. And then there's the NeMo Agent Toolkit that complements everything that Microsoft gives you for like really getting in and tuning agents. I'm always interested in like, well, exactly how when this model is stood up, exactly how is it going to partition its work across my 4 DGX Sparks, right? Because the latency between them can absolutely kill me. So you get into tensor parallelism. I'm going too far afield. So When it comes to training scripts, we have the Nematron cookbook and the Nematron recipes for common workflows. Go take a look at those. And lastly are the blueprints, and mentioning 3 here, there's a blueprint for agentic research, there's a blueprint for video search and summarization, and there's one for RAG applications, because those are super popular, and more. So take a look at these things. You come to our website, build.nvidia.com, and you'll be able to see all of the NeMo things and get your hands on them and play with them and enjoy them and use them in what you're doing. How about the next slide? Yes. So this is the NeMo models that are directly available through Microsoft Foundry model catalog. So don't need to go to build.nvidia. They're right here. They're right there. And that includes Nematron models for chat, for reasoning, retrieval, parsing, safety, vision, speech, all of these things. So if your team is already building with Microsoft Foundry, you don't have to go anywhere else. They're right there. Next slide, please. And these too. So here's some more models from the Foundry catalog, and more are being added every week. Next slide. Okay. Now the data sets, the Nematron open data sets are a gold mine for you, and they're all free. They're massive data sets that you use for training your models, as I was saying. For instance, let's say I've got them broken into some categories here so you can get your mind around them. So for foundations, you're building foundation model, you would probably be very interested in the Nematron pre-training data sets. They were taught how to code and STEM and safety and chat. Make them be good, multilingual, make them be good citizens when they get out there and do things in the world, right? Nematron Climb Lab is optimized pre-training mix, and you can read about why you would want to use that if you'd like. For alignment, we've got the Nematron post-training for code and STEM and chat and reasoning. We've got help steer data set, which makes your agents be helpful and factual and coherent. And then we have Nematron VLM2, Vision Language Model 2, right? So that's for OCR. It's very difficult to open a PDF and make sense out of it. There's a graphic there, there's a table there, there's text on, you need to, and so this data set tests a model's ability to do that, right? So, or trains it, look at it either way. For safety, we've got Nematron Content Safety 2 for human LLM interactions. We've got AIQ Agentic Safety for contextual risks. We've got Content Safety 4 for multilingual training. And we've got Content Safety Audio for, multimodal. For sovereign AI, there's Nematron Personas for grounded national demographics. There's Nematron, PII for that sensitive information, and Granary, which is an open multilingual speech corpus.
Yes, and before we move to the next one, Don, just to share something, because all the Nematron tools, frameworks, and more are amazing. Last time we were together with Don, we were talking and we built an audio solution. We start to use the parakeets and the models to do audio, and I learned a lot about that. But early today, when I see this one, the Nematron Content Safety, this is super nice because it's kind of, we are moving to a place where we are going to have models and agents and tools that they are all going to work together. But I pick up the solution that we created, I think it was last month, that is all voice, kind of a voice agent. And I put this one on top at the beginning and at the end. And it basically did what the 5-year-old kid will start to do. I start to use some bad words to talk with my agent. And this model filter everything in a very, very nice way, in a very polite way. And it's multimodal, multi-language. I did it in English and I did it in Spanish. Spanish is my first language, and it worked. I don't know, it was literally a 5-minute Hello World demo, and it works great. And I really, really like to have this because, as we talked before, and you mentioned that, we have the Guardrails in the cloud, but we also have so many tools that we know how to put it all together. That's the apple that we want to expect. And because we have this, hey, at least everybody, give it a try. They are very, very easy to use. Sorry, Don, I put there, but after this morning, I give this one a very small test, and it was, wow, this is amazing.
Yeah, that is fantastic. You know, these models, they start to differentiate as you train them with different data sets and as you set different goals for them, and your agents will take on that same characteristic. So there's no such thing as like a dumb model and a smart model. It's like, well, what are you trying to do? Yeah. And then picking a model that's been trained close to what you want and then fine tuning it up, and maybe grounding it with some RAG, which we're about to get into right here, to help it do its task, to understand the vocabulary of that domain and the skills and the workflows of a particular domain. So, or to be able to pull them off, you need the orchestrator to actually do that work, but to have the model respond correctly to the orchestrator. Okay, so let's take a look then at this. So I mentioned there are a number of blueprints that we make available. And so, you get a diagram, you get all the source code, every blueprint is up on GitHub. So you can just go in and start implementing, use the pieces you like, leave the other pieces behind, but read the blueprint. I mean, somebody took the time to write it down, and I know they're brilliant because I work with these people, and you might as well see what they've done. So this blueprint is one for retrieval augmented generation. So just take your eye to the bottom left-hand corner there, and you'll see that multimodal documents are ingested. And then the blueprint breaks those documents into page elements, graphics, tables, text, using Nematron parsing and OCR and document understanding models. Those extracted elements are then embedded, right? You got to run them through an embedding model to turn, tokens into a vector. So now you've got a vector. You can store that into a vector database, and that's shown here. You can see NVIDIA cuVS. Those are libraries that knowing that everyone needed to create vector databases and they're all out there and we needed them for ourselves for different things, we're like, you know what? How about if we take we do this all the time, take the fundamental algorithms that all vector database vendors are going to need, get our research geniuses on it and just put them out as open source and go, hey, making a vector database, use these. You'll be glad you did, right? Because it runs really good on our GPUs if you do, and solves a lot of problems that could otherwise crop up. So cuVS is in there. So when a user then, let's do the prompt. The user comes in and asks a question. The query is first checked for safety. And then, right, you got to create it. You got to take the tokens, create an embedding. And then once you've got a vector, you can go to your vector database and say, give me the top 5, things that are near this vector in the latent space. And you get 5 things back. Now, don't just use them, okay? Accuracy is not so good if you do that. Go through a re-ranker. I've seen the numbers with and without the re-ranker. I've never done one of these, but if I did, I would definitely put a re-ranker in there to take all of those possibilities of things that should go into the prompt and do a re-rank so you get the best. And then pass that on to a model. And it will generate a nice grounded response. And then on its way out, do another safety model on the way out, just to make sure nothing went awry there for you. So there's typical, everyone needs to do a RAG application at some point. And there's just one of our blueprints as an example. You bring me to the next slide. And so then this slide shows an end-to-end workflow for building and improving an enterprise AI agent using various NVIDIA technologies on Azure. Right? We complement all of the things that you get there on Azure. And I'll use that thing from NVIDIA. Okay, oh, this could help me over here. Oh, look at this other thing over here. Yeah, there's quite a few things. And that's why we're doing this webinar. Our companies work very closely together to make sure that the NVIDIA technologies are properly integrated into all things Azure, because you need to do things the right way. You need to tie in right to the greater framework that everyone's programming to. So it starts with the use case. You need to, before you choose any models or tools, you have to define what is the business task, who are the users of this system that you're about to create, this agent, what data will be required, what will the success criteria be, things like that. Next, you have to prepare data and generate other data if you've got holes or just because. Do your data preparation and data generation using NeMo Curator and NeMo Data Designer to clean and create all of your data that will be used for training or for tuning or for evaluating. Then you select the right model, as I was mentioning, with NeMo Evaluator. We'll compare for speed and quality and different metrics. And then to help you build the agent, there's a NeMo Agent Toolkit. Yes, there's the framework here and the toolkit there. They all play a role and are complementary. So I used to say just Google it, but now just AI it. How do these two overlap or complement each other? Boom, comes right out. At least it did for me. So when I typed it in. So you've got from there, the agent is deployed. The easiest way to distribute and deploy a model is with a NIM, because it's a Docker container that contains the model that you really care about, but also everything that's needed to run it, right? You got this version of that and that and this and that, and that one got a bug, a CVE reported against it. So we're patching these NIMs, and they're just really convenient. You just stand up the NIM and boom, everything is there. There's it takes a lot of hassle and mystery out of the whole thing. Stand it up. Now it's at an endpoint, you can start using it, right? It's just a container that's up and running. And then once your application's up, of course, you should create a data flywheel that monitors what's going on, right? If the agent, is wrong once or two times with me, I'm okay with it. But if it keeps doing it, I get a bad tone of voice with it, and anyone would, I think. And so you really need to have the agent in such a way that it can be understanding how it's doing and improving itself while it's out there running. And that has to do with instrumentation, but also just sort of generally how you're going to do a flywheel. And we've got a bunch of technologies to help you there too. Back to you, Bruno.
Yes, sorry, I was on mute. I am taking a look here at the mute button, and more sorry about that. And yes, and after we've seen all of the stuff that we have, let's move to the place that how we start to land this on Azure. So one of the technologies, one of the services and the pros that we have there is the Azure Container Apps. It's literally where we have containers running on Azure. That's the names there, basically. But we also have containers that using GPUs, and these are serverless. So basically, they up and down on demand, and they are very, very powerful. And I like this because it's a fast way to deploy. As you've seen probably that I have run out of quota, because this is very fast way to deploy and provide GPUs to your needs. And by the way, there is a lot of the family of options that you have there. It's huge, from, I will say small, because I think that the T4 for me is small, because I see another what they say, whoa, this is crazy good and amazing. So there is a lot of stuff there. In the same concept, in the same idea, you have the chance to do your Foundry models running on GPU. If you want to use a model that isn't Hugging Face, in example, is one of the models is not there here, I will probably say yes. Try to use always your model that came from NVIDIA or from Azure. There are parts of there. But if you want to run a model that you train and more, and you want to run your model, a Foundry model in GPU, you can run this there. And this is great because all of these powerful GPU give us the chance to have all together, as Don was talking right now, we can run these NVIDIA models based on NIM, that is the package ready for enterprise to do this, or we can even jump to more advanced scenarios like Spark, where we have GPU workloads and more. I'm not an expert of Spark, but people really, really like it. So let me show you, based on the scenario that we've seen before, when I have the chatbot basically running locally, let me show you how the chatbot works when we run with the model deployed in the cloud. So I'm going to basically deploy the same model, but in the cloud. this time in the cloud. And let's run this in, and I'm going to show you how this run there. So let me go back to the videos and let's run this one. And in this scenario, what we are going to do is we are going to run the same C# application, but we are going to run this application using a remote container apps that is using a GPU and is having the model loaded there. So instead of running the model locally, we are going to run this on the cloud. And we have here the application is going to use, as I said, the remote endpoint. We have NVIDIA NeMo Mini 4B Instruct as the model there. Let's ask a question. And we have the connected resource there. On the right, we are going to see how in the Azure resource, we started to see that the model is loading and responding. And if we run the application again, and we ask another question like, please solve 2 + 2, we are going to keep seeing the model working with more logs and more. An interesting part about this is that this model is running literally using a GPU. If I go here, let's maximize a little the resource. If I go to the console and we start to take a look at we connect to the bin, we can run a command. Let's maximize this so we have a better view. We can do NVIDIA SMI, and we are going to see here that we have a Tesla T4 right now. We have the temperature, watts, in and out, and also we have the GPU working here, loading and more. And this is amazing. We can start to create container apps that take advantage of the GPU. And if you are wondering how hard it is to do this, first, of course, you need to have access to the GPUs there, and then it's just part of the deploy configuration. So if I go back here to my Docker file, let's minimize this. So we have here the Docker file for the application, which is basically going to create a function, not this one, another is going to create a function, and then it's going to publish the function in Python. We're going to see this later. But we have here the container app bicep, the deploy application here, where we define at the bottom somewhere here, we define the consumption GPU profile that is going to use the T4 for NVIDIA. So the name in Azure up to today for this specific profile is consumption GPU NC8/4. So this is the GPU profile, is the one that is going to define when the container app is created, the resources that they're going to use. If we go back here, I always forget how to do this, but I think somewhere here in the application, it's not the application, it's in the container apps. If I go to the container app environment, which is not here, it's in the next page. Where is my container app environment? There it is, it's in the bottom. So if I go to my container app environment and I go to the settings and I go to see the workload profiles, this is the one that is going to be named GPU profile, and this is the one that connects here with the GPU profile, and it basically says we're going to use a Tesla T4 from NVIDIA, which is an amazing GPU to use for them. So we have literally the same, but this time running with GPUs on the cloud. And if you are wondering, okay, how can I start? What is a functional demo, or how we can start to use GPU instead of using a standard model to do chat? Kind of the hello world in this scenario is to use one image generator model. And I have a colleague here that created a blog post. I think this is from early this year. Yes, it's from February this year. And it basically uses an Azure function that has a GPU. It's powered by the GPU that use and is doing image generator. And what it's going to do is going to run a stable diffusion model. It's going to download the model and generate an image, and it's going to do this in an Azure function. So when you do a prompt with the post that you are going to pass a friendly robot chef cooking pasta and a cozy chicken, it's going to generate the image. Let me show you how this works, because this is also kind of a nice one to do. And this is an Azure function that is taking advantage of the GPU's capability that we have in Azure. And in this scenario, this Azure function is going to do something which is kind of the hello world that we have when we create we're going to start to use models that we can download models. It's going to generate an image. In order to do this, we're going to use a stable diffusion model. We get one from Hugging Face, and we're going to use the stable diffusion pipeline libraries to do this. It's very easy. Load the model, check for if we have a GPU available. If we have a GPU, we're going to use CUDA. And then somewhere here, we have a post method to do the generation. And we have here the generate, and basically we have all of the parameters that we are going to receive for this. So we need the text of the prompt, and then we have a negative prompt if we want, and then the number of steps, and also the scale. With all of this, it's going to generate the image. This is all standard CUDA inference and pipeline, and at the end is going to return a JSON with the success true and then the image in stream. I know there are better ways to do this. This is just a sample, just a demo, but this kind of works. And we also have a health endpoint here that we can use to, and it's going to say, okay, this is the devices that we have running right now. So if we want to take a look at the health endpoints, I have it somewhere here, and we refresh this. Let's do a pretty print. We are going to see that, yes, again, this model is healthy. It's using the Tesla T4 one, as you've probably seen. I'm a big fan. I'm using T4 everywhere, and the model is loaded. Because the model is loaded, I can quickly go here. Let's minimize this. Let's also close the function. And if I generate a new image, all of the images are going to do is going to be here in this demo output folder. It's empty right now. So let me copy here a small prompt to generate some Canadian images, which is going to say, okay, generate a pixelated image of a raccoon in Canada with 50 steps. Of course, it's going to take some time. The model is loaded, so it's going to be faster. But after a couple of seconds, we should have the image. And by the way, this PowerShell script is also going to open the image here. So we have it here, kind of nice. Hey, let's do something else. Let's do an image of a moose in Canada. Let's see how it works. Let's run this one. Again, it's going to take some time. Step 1, 2, 3, 4. Step 3 is going to decode and open the image locally. And after these 2 runs, we should see, there it is. Okay, kind of a nice moose. And both images are here in the demo output folder. We have here the raccoon, and we have here the moose. The function is loaded here. If we go here and do the same, this is the function. If I go to the console, I open a new console with bin, and I do, let's maximize this, and I do the NVIDIA SI. I will see that the NVIDIA is running here. And if I open the logs, I will be able to see also how this is running all the time. And this is one, as I said, hello world example of using a local model to generate images with GPUs on Azure Functions. And hey, this is kind of a nice way to show how you can use it. But remember when we start to talk about agents, and we know that we can have all of these deployed in the cloud, so we can have the GPUs. Of course, the best way to deploy a model is not, you can host your own model if you want, like I just showed, but probably the best way to do that is use a NeMo container. Because the NeMo container is going to add, on top of the model that you choose, is going to add traceability, is going to add security. As Don mentioned before, they're going to have some branches and version and updates. So it's really the enterprise level, and the enterprise way to do this. In my resources, in my container apps here, if I go to my resources, to my Nemotron dev resource, what I have here, I have my original one that I deploy and host, and then I have my NeMo deploy, because also NeMo is available for everyone to use. You can test your NeMo resources and more. As Don mentioned before, if you want to access to this model, blueprints, and more amazing stuff that NVIDIA has available, you need to go to buildnvidia.com and then create an account there. Once you create your account, you can have an API key, and you can start to use, in example, one of the models. And by the way, you have the Nemotron models, but you can see here, they also have the chance to download the Kimi models, Quen. I see a DeepSeek here also, the Nemotron Nano, that I really, really like because this is a multimodal model and more. You have the blueprints, which are basically ready to use, as the RAG one that Don showed before, that is everything is here. And most of them, if I go here in example and I say, okay, I want to use something from developers for, let's also filter by AI, something here, NVIDIA AI and more. Most of them are also have a repository in GitHub that you can go and use it. So there are plenty of options here that you can literally later move to Azure. But one key part when we are talking about agents and more is how you make an agent to manage states. How you literally make an agent to persist, to stop in one moment and move to the other. And the way to do this is using durable functions. And the best way to explain durable functions is to basically show you a video of this. So let me go back here and let me show you how this works. And this is the core part of the story, because in a standard scenario, we have a trigger for an agent, which is a simple HTTP request. But instead of running everything in a single request, in one request, we are going to schedule a durable orchestration instance. We are going to have an orchestrator that is going to execute in a step. First, in this scenario, we are going to construct the prompt. Then we are do the model inference. Then we are going to do the result packagings and more. After each one of the steps, the durable function checks point state. So if the process recycle, it's going to be able to go back and resume for the last completed activity. That's the difference between a cool demo and a production safe behavior. And now we also have NVIDIA here, because if it's really here, we are going to use the NeMo instance instead of having our own deployment here and there, because what we have there, we are going to point to the deployed NeMo model that we have there, and hey, this orchestration logic is going to be the same. So let me go back here and start to use. So by the way, what we are going to use is the durable functions that we have in Azure. So let me go back to my virtual machine, and let's take a look at this. All of the code is already here, it's available. This is a C# demo where we have a set of functions. This is Azure Functions, where we have the start NVIDIA flow that's going to start the flow and give us an ID, and then we have the orchestration for the flow. If we want to run this, if we want to take a look, we can see the orchestrator step. This is running locally in a Docker container, and we can see here that there are already some instance there. It's refreshed every 10 seconds, so when we start a new one, it's going to be there. And the idea here is that we can start a new process, and the new process and the new activity is going to do that. So if I start a new activity, we are going to see that the first step is going to create a durable traceable execution ID. This is after a couple of seconds, we are going to have the instruction there on the orchestration. And when we have this, we are going to be able to see the steps. What we see here at the right is there it is, that's the orchestration emulator, and we can enter here and start to see the steps. Each one of the steps is going to be analyzed there, so we are still running, we are still continuing, we are still working there, and at the end, what we are going to do is have the chance to go to each one. If for some, whatever reason, I stop here, we can open this again, and we can continue from here. The idea here is that, hey, we can finish this, let me finish, let's do all of the steps, we have the full amazing all response here and data verification, so we have here. But what we just did is basically did step by step. Everything was recorded in the durable function emulator here, and we can get back here and start to see how we work. We can take a look at the payload, the inputs, the output, the status. We can see each one of the steps, when they happen, and more. And the cool part about this is that this platform not only gives us these steps, it also gives us access, in example, to emulators. If I maximize this, we are going to see that we have agents, entities, schedules, working, and more. So we can start to sync on a full platform, on a full scenario that will really help to work on enterprises. So at the end, what we just see is the takeaway here is very simple. We can narrate and operate the workflow step by step without losing production rigor. Durable orchestrations give us control, observability, and recovery. GPU give us inference, give us speed, where it matters most. So we have the best of the two worlds, put it all together here. And if you are interested, because we are getting to the end of the session and we have some content that we are not going to be able to show, but if you're interested to see a full implementation of this, we have this repo, the Travel Agent Planner, that is in .NET using Agent Framework, that basically use durable agent. Everything that we talked today about having agents that they are ready to be working in enterprise scenarios, this is a scenario that we can talk about and share. So let me share this in the chat so people can take a look at the repository. I think also, thanks. Andrea already shared it here. Thanks for this. But here we have the durable agent. It's ready to deploy. And as you can see here, we have a React front end that is using Azure Functions, that they are managing the durable conversation, and they have an orchestrators. And in the back, we have a Redis for the cache. We are using Azure OpenAI models. There is a version that also use NVIDIA models and more. And we have the durable task scheduler to do all of this. The important part here is that, let me go back quickly to the slides, is that if we take a look at the architecture, we have the front end, we have the planner agents here, and we have a couple of agents doing booking tools, itinerary planning, and more. But what we can do, and this is the moment that I invite everyone to start to play and learn this, you can switch these kind of things. You can switch the agents to be written and hosted with Microsoft Agent Framework, to be created with NeMo toolkit, because we have the NeMo toolkit for the agents. And I have a demo, and I'm going to write a blog post about that, how easy it is to create an agent using NeMo toolkit and also to connect it to Microsoft Agent Framework. And if you want to do, in example, that connection in Foundry, we have here as part of the, when we work and talk about agents, if we want to connect with tools, we have the set of tools. And if I want to connect a new tool, we have, of course, internal tools. And in custom tools, we have agent to agent. And this is the place that we can connect agent created with NeMo toolkit, in example, with the NeMo toolkit, agent toolkit, sorry, to be connected with the agents that are working in Foundry. So it's all came all together here. And the final part, because I'm here in Foundry, let me go back to the slides. The final part is that we don't have time to do the demo, is that once we have all of these agents, once we have all of these powerful GPUs, once we have all of these templates that allows us to create enterprise-ready applications on the cloud and more, we have tons of knowledge. When we are creating this Work IQ, Fabric IQ, Foundry IQ, everything IQ on top of these major products that we have, because we know that we can start to learn from this knowledge. We can start to query that knowledge. We can start to learn and connect these kind of things. So imagine that everything that we've seen today is part of Foundry IQ. But if you connect that with Work IQ, which is if you are using the Microsoft stack for Teams, Office, and more, you will have a lot of agents in the cloud that can be able to talk with your enterprise applications and documents and your Teams chats and more, and you can have a lot of knowledge, interaction, and more. And by the way, these agents can run in their own way. They can run kind of isolated, have their own mind, have their own ideas, and they can do their own stuff. So putting all this together, the IQ parts are very, very important. And once again, take a look at our announcements in Build in 2 weeks, because there are going to be huge announcements around this. That said, we are at the end of the hour. We only have 3 more minutes, I think. So if you want to try this, please let me go back here to this. Take a look at the serverless GPU. That's a very, very easy entry point. It has the best of the 2 worlds. It's the best implementation, the collaboration that we have because Microsoft and NVIDIA. You can also have NIM deployed there, so you can take advantage of those models, pick up one of the blueprints, play around with the blueprints. You can deploy them in 2 clicks to Azure. They are very easy, and you can learn a lot in the process. But the NVIDIA serverless, the NIM serverless GPU is, I probably say, the best, the easiest entry point to start to work here. And then you have functions, you have hosted models, you have more. And I need to check if we have any other question. I don't think so. But we're at the end of the hour. Don, did I miss something?
You missed something. What can I say? Those were an incredible set of demos. So many light bulbs came on for me, Bruno. Thank you. You pulled me through all those different things. And I'll go back to the recording too, because a couple of them, I gotta go and see that one again. So thank you. It was fantastic.
No, and I want to thank also the people here staying with us and more. If you want to contact us, you have some, oh my God, this is so small. Sorry about that. We need bigger fonts here. We need to have there. But if you have good eyes, I don't have good eyes. Also, late at night, I see less and less during the day. Those are our connection. And hey, someone was asking a question for me later after this on LinkedIn about NeMo and the agent toolkits and more. Feel free to drop question. I'm happy to help. And if I can't help, I will try to find the person who really knows this to do this. So that said, thanks everyone. We are going to go back to the production team. I think we are at the end of the hour, and see you all in the next one. Goodbye, everyone.
Thank you, Bruno. Thank you, Don, for today's amazing presentation. I mean, Don said it just a few minutes ago, but those demos were incredible. And it honestly made us really happy to see such an interactive chat. So thank you all for joining today. And if you happen to be catching up with this session a bit after the live stream has happened, like Bruno mentioned, the resources are here. Feel free to reach out to the presenters. They will be more than happy to help you guys out. With that being said, we do appreciate your opinion. We value it. So I have a QR code right here, and I will also drop a link in the chat if it's a little bit easier for you guys, if we could steal just a couple of minutes from your time so that we can get your feedback on today's session. With that being said, thank you so much. I am Isabel from the Reactor in Asia Pacific, and we hope to see you again soon. Thank you, everyone.